All right, guys, how you doing? This video here is going to be about problem number 79. It's the last problem in that first practice set, and it's also a really good vehicle to discuss and demonstrate some conditional probability and this whole very strange idea of independence. I hope you've had a chance to try this problem. If not, you might want to pause the video and go have a look at the problem yourself. On your own, just for your own. It'll be better for you to try it on your own and then maybe come check this video out if you have trouble. Anyway, so let's get into the problem. It's about a child's game called Build a Farm, and a person playing this game first takes a spinner and spins it, and it's either red or blue. And what they do is, depending on which color they got, they pick little plastic animals out of a box. So if they spin red, they pick little plastic animals out of the red box. And if they spin blue, they pick them out of the blue box. The first problem that they ask you to do is to make a tree diagram to represent the sample space for this problem. So here's your two branches for your spinner, 1/2 probability for red and for blue. And then in the red box, it turns out that there are 10 plastic chickens, 10 plastic pigs, and 10 plastic cows. So there's 30 altogether, and there's a 1/3 probability of picking any of those animals, a chicken, a pig, or a cow. So if you recall, on a tree diagram, the way you calculate the probabilities is to just multiply these probabilities down the branches. So 1/2 times 1/3 is 1/6, and that's the probability of picking a chicken in the red box. So red, spinning red, and getting chicken. So it's 1/6 for all of these. All right, down here in the blue box, it's a different distribution of plastic animals. There are 10 plastic animals. 5 of them are chickens. 4 of them are plastic pigs, and the prize of all is the blue cow, apparently, because there's only 1 of those. So one of the things that they ask you to do is to figure out, well, what is the probability of getting a cow? They don't say a blue or red cow, they just say probability of cow. So you can get a cow from the red box, and there's a 1/6 chance that you'll do that. Or you can get the cow from the blue box, and there's a 1/20th chance of doing that. That's 1/2 times 1/10. That's 1 out of 20. The probability of a cow, since you can get one either way, from red or from blue, then what we're going to do is add those probabilities together. So 1/6 plus 1/20th, here's the little bit of work for that, and it's about 21.6 repeating, 21 2/3%, or as a fraction, 13/60. That's the probability of getting a cow. Okay, so they handled that, and then what they did in the next part of the problem was to show you this area model for the same probability, a different way to model the sample space for this game. All right, and it's an area model. I think it's going to serve a good purpose here for this problem, especially in the conditional probability questions. But they first want you to verify that you still get the same probability, of course, so we get all the numbers in the right places. It's 1/3, 1/3, 1/3 from the red box, and 1/2 for chicken, 2/5 for pig, and 1/10 for the cow from the blue box. And so once again, you multiply those probabilities. So there's a 1/6 chance here and a 1/20th chance there. It's kind of hard to read, sorry. And you add those together and you get the same number. So the next question they ask then is the conditional probability question here. They're asking this. They ask the question, if you know that someone has a cow, if they have a cow, what is the probability that they got that cow from the red box? All right. So that's how they describe the question at first, and using this kind of this conditional probability phrasing that we use, the question is asking, what is the probability that you spun red given that you have a cow? All right, so the cow is the condition in this question here. You have a cow, did you get it from the red or from the blue? So to figure out the probability of red given cow, if you remember that formula from the first video, it is a little fraction that you have to work out. So in the top of the fraction is the probability of red and cow, and in the bottom of the fraction is probability of just cow. This is kind of like our new sort of substitute sample space for this, because we know we've got a cow, but we don't know if it's red or blue, or we're just trying to figure out what the probabilities are for that. Now look at the area here on this area model. This entire green shaded area there, that's the probability of getting a cow. It's 1/6 plus 1/20th. All right, that's our fraction. So that's what this green area here represents. getting a cow. And if you look at it, this piece right here where you got the cow from the red box, that's a lot bigger than this piece here. So out of this total area, most of it, or a majority of it, is taken up from the red box cow. All right, so let's work out the probabilities there. The probability of red and cow, well, that's what that is, 1/6. And the probability of cow is the sum of all of them. So we're going to take 1/6 divided by 13/60. That's the probability of cow, right? Right there. So this number divided by this number, okay, I'll take the top fraction and multiply by the reciprocal of the bottom fraction, because dividing is always the same thing as multiplying by the reciprocal. And that gives me 10 out of 13, or about a 79% chance that if I have a cow, I got it from the red box. All right? So that's the conditional probability question there. Then they ask this other very important question: are these two events, red and cow, independent events? All right. So once again, that video, the first video there, illustrated this little test to see if if two events are independent of each other. If they satisfy this equation, they are independent, is essentially what's going on there. So if the probability of A given B equals the same thing as the probability of A, then that means A and B are independent events. In a sense, what this is saying is very kind of basic. If the probability of A given this condition B is the same thing as just the probability of A, then that means the condition B did not change the probability of A. Does that make sense? It's saying that this condition here that we set up, A given B, didn't really matter. It's saying that, B is whatever it is, A is whatever it is. These two things, this thing does not influence this. All right? And there's some interesting algebraic interpretations of that too that we'll get into a little later. But when you do this, the red given cow part, all right, that's this A given B, just the first part of this equation, the left side, I should say, that's 79%. That's what we got right here. But the probability of the probability of red is 50%. The probability of red is 50%. Therefore, so they're not the same number, in other words. I mean, 79% does not equal 50%. So this equation does not work for these two events. That means that A and B are not independent. All right? If it equaled, then they would be independent. If it doesn't equal, then they are not independent. And actually, the phrase that we use is we say that they are associated. And that's kind of a separate discussion all by itself. Why don't we just say they're dependent? Well, that's actually making a claim that we don't necessarily have enough information to back up. We can say for sure that there is some kind of probabilistic or statistical even association between spinning red and getting a cow, but in the general sense, it's a stronger statement, and you may not be able to back it up with evidence to say that they are dependent on each other. In this case, they are, but in general sense, what you can say for sure in every case is that they are associated. Whether or not one is dependent on the other is kind of a separate question. So we don't really use that word dependent as meaning not independent. We'd say they're not independent or they are associated. All right? Okay, that was a long video there. I hope that wasn't too confusing. Please leave me a question in the forum if you need to. All right? Bye-bye.